there we go. Okay, great. So, my name is Levi Wolf, and I am the convener for the Geographic Data Science unit this term. So many of you have done spatial modeling in the past 2 years, and you're very familiar with sort of doing applied data analyses and particularly getting data inputted into R in a semi-clean format, and then doing some kind of exploratory analysis, maybe a regression or two, and making some plots. The whole point of this course, this particular module, is to kind of deepen your understanding and your capacity to do that. So it's all about kind of enriching your understanding of working with data, transforming data, and then trying to use some slightly more advanced regression modeling techniques that kind of open the door to nearly any other type or style of analysis that you might find. So we're going to go pretty far beyond what you've learned so far. And I think that having taught this last year for the first time, some students find this to be a very rewarding course, and other students find it to be very challenging. But no matter what, the way the course is constructed is supposed to let you score well enough as long as you just diligently do the reading and do the work. So I think you will find that this is a seriously engaging, very fun, and very challenging course. And I'm extremely excited to be able to teach it this year. That said, because of some sort of familial obligations that I have, I'm not able to teach in person this term because someone in my family is immunocompromised, and in order for me to visit them when returning to the US, I have to be basically COVID clean for 2 months, according to the doctor. So that's kind of my main reason why I'm not teaching in person this term. That said, the course times and schedule that you have, lectures on Monday, practicals on Thursday and Friday, the Haggett and Heppel should be booked out for you to attend class from those spaces if you would like. Could I get a show of hands to see how many people would be interested in attending in person with everybody else in the course? Okay, quite a few. Okay. Well, so I think awesome, thank you very much. One of the kind of frustrating things I think about the way that COVID is affecting like the way that we teach and all that kind of stuff. I'll get to you in a second, Patrick. Is that that kind of cohort mentality that we were able to build in the Haggett oftentimes is challenging. So I really want to make sure that you have that feeling of community and co-learning, because honestly, I think that last year running data science, that was vital for many students. So if that's something that you're willing to do, then by all means, please, please do that. However, I do not expect you, nor am I going to be present in that space. So I don't expect anybody to do that. There was a question. Yeah, Patrick?
Sorry, I don't have anything.
Alternatively, if you do have a question at any point, you can feel free to put it in the chat and I'll read it out and answer it as well. So maybe that would be an easier way. So what I would like to do now is sort of show some of the course material and do some of the introduction to the course. So can everybody see my screen? It should display the Geographic Data Science syllabus. Awesome, great, seems like it's working well. So what I'd like to talk about a little bit is the course structure, because sometimes that is surprising to students. So the main kind of thing that I think is important is the MARC structure. So as you'll see here, the course will have, basically these 2-week blocks, and each block is going to be structured around a specific topic. The first block is 3 weeks long because this introductory week is kind of, sometimes people are just getting their heads around stuff. And so I like to pad it out in the front and then make sure that we have consistent 2 weeks in the back. So each chunk is going to be about one topic. So that means the course overall is structured in 4 chunks. The first chunk is going to be about thinking about tidy data and sort of theories about normal forms for data, how to manipulate and transform it. Each chunk will have 2 lectures and 4 2-hour labs. One of those will be on Thursday, one of them will be on Friday, one of them will be on Thursday, and then the Friday one will kind of go over the answers. The second Friday lab will go over the answers to the assignment that was due on the Thursday at 2 p.m. So the assignments are going to be released on the Monday of the second week of the chunk, which, I may change that depending, but they wanted to make sure that you had enough time to kind of do other work and then focus on the data science assessment. So that will drop on Monday. It'll be due on Thursday at 2 p.m. And then we'll go over the answers together on Friday, on the Friday lab. So all of those assignments are posted in the syllabus's schedule section, which I hope that you've consulted. And in addition to that, I've also posted the reading for each chunk. So the reading is quite important. And my suggestion would be that you attempt to do the reading and then look at the workbook. So the workbooks are kind of a combination of code and text that I've written to kind of explain the code. So here we're viewing the very first workbook. It'll have you read some data in and then conduct a sort of short analysis that will be used with the data and to illustrate the concepts in the chunk. So my recommendation is to do the reading and then take a look at the workbook, maybe go through it yourself in one of the labs with the demonstrators around. And then when we assign the assessment, you do that in the labs as well with other people. And also you can book time with me, you can work with your peers as long as you submit your own substantial contribution as your assessment. I don't mind if you're working with your peers. So I kind of want to build that co-learning space around doing the workbooks and doing the assignments. The reading for the course comes primarily from 2 books, and well, 3 books really. So the first book is the R for Data Science book. And this book is written by Hadley Wickham and Garrett Grolemund. It's available online for free, covering nearly all of the topics that you're going to need about learning R for data science. Some of you may have seen this book already because I've recommended it in Spatial Modeling 1 and 2 when I've been involved for kind of fundamentals of how modern R is used. The second book that we'll be using is this book, Data Analysis Using Regression and Multi-Level/Hierarchical Models. This is kind of a straightforward presentation of linear regression approaches for the social sciences. It's kind of the classical text on this topic that's given to students in advanced undergrad and sort of master's level coursework. So this is written sort of with a social science angle. Andrew Gelman and Jennifer Hill are both statisticians who work across politics and sociology. So this is kind of that traditional statistical lens. The introduction to statistical learning, on the other hand, is a presentation of statistical concepts from a machine learning perspective. So this is really the first book that's designed for getting students introduced to data scientific or machine learning concepts. And it's an excellent book, but you'll notice that sometimes Introduction to Statistical Learning and the Gelman-Hill data analysis book will cover the same topics and use incredibly different language. So I'm assigning readings out of both for different chunks, and then also demonstrating where you may be able to read content from the Statistical Learning book instead of the content from the Gelman book, if you prefer that. So those are the three readings that you'll be using. The sort of three main canonical sources: R for data science, applied regression modeling, and intro to statistical learning. They're all available in full PDFs, either on Blackboard or from the author's website. So you should have no problem accessing the texts available in the course. You can also purchase the texts yourself, and the library should have a couple of copies of these texts. Are there any questions on the reading? I'm not seeing any in the chat, but maybe I'm missing something. There we go, chat from Georgia. Will there be anyone to help us during the lag practical, or is it just timetable to help us organize ourselves? Great question, Georgia. I'll be there, and so will our postgraduate demonstrators, Lenka Hasova and Tom Statham. So we'll all be there during all of the practicals. How we'll kind of arrange the helping you with the practicals is by using remote control over Zoom and breakout groups. So basically we'll all be in a call. If someone needs help, they'll either raise their hand or comment in the chat. We'll build a breakout room for that student, and then we'll help on a particular component. And then that way, if there's kind of common errors or issues, we can also announce those to the whole class. So that's how the practicals will work. It'll kind of be a call where we'll go into breakout sessions for individual help. Wonderful. So with these three readings, or sort of three books and sources, I've posted the entire structure of the course in the schedule section. So again, the typical chunk will have an introduction in the first lecture. We'll have maybe starting on the workbook for the Thursday and the Friday. I'll give the assignment on the Monday. We'll work together on some of it Thursday, and then it'll be due that Thursday. And then we'll go over the answers on the Friday. Pretty simple 2-week cycle. One important thing I haven't mentioned yet is how it'll be marked. The whole course is going to be split into two components. One of them will be these assessments, and then your final, which will be given, I think, in week 12. You'll be graded on the best 3 out of the 4 workbooks that, or out of the 4 assignments that you do. So if you do 3 assignments and you get to the 4th and you're just like, I'm done with this course, I'm totally over it, data science sucks, I never want to do this again, you can just ignore it. You could just not submit anything and still get a really good grade as long as you do the final. Alternatively, if you attempt every single one, I'll pick your best 3, and then that's what your assignment mark will be used. The final constitutes about 2, maybe 3, somewhere between 2 and 3 assignments. So it's still a lot of points, but it's not sort of supercharged in that way. So doing well on the assignments, just doing the diligent small bits of work throughout the semester, you will do very well in this course. Are there any questions about the materials, about the schedule, about the mark structure? No? Okay, I'm not seeing any. And no other individual questions, so cool. The last thing that I wanted to talk about a little bit is the this last chunk here, chunk 4 or block 4. I've scheduled a kind of teaching block in that area to do with a topic that some students might find useful in their dissertations, and sort of generally constitutes a very important topic in data science. Now, I want to tailor this chunk of the course to what you want to do. So you may have seen in Blackboard, which I think currently is down for me. Yeah, so I can't show you this directly, but scrolling up to the top on the quick links, there's a Blackboard forum for the course that if Blackboard was currently alive, we could use. In that forum, I have suggested that we sort of come together and talk about what we might want to do in that last chunk. So there might be people that are interested maybe in doing time series modeling for people that have data sets on climate or maybe longitudinal analyses. Or maybe, you know, if you're interested on imagery, we could talk about image classification and methods that are used there in sort of data scientific ways. So I want that last chunk to be kind of flexible. If I don't get a sense from the course that there's a strong direction that people want to go, then we'll just proceed through the planned material and everything will be fine. However, I want to give people the option because this course primarily needs to be tuned to solving the real data analytic problems that people have. That's the point of data science. As Tukey said in his 1960 paper, the point of data science is to solve the problems where they are, not to teach you an abstract theoretical method that you then try and squeeze all the problems into. So that last little bit, if there's anything that people are finding that they really start needing on their dissertation or sort of kind of, I'm even talking about like, how do I write an effective presentation of quantitative results, or how do I make nice plots? Stuff like that, we could fit that into the fourth slot if people are interested. So overall, we got those 4 chunks. You've got an assignment due every week, and then we'll have a final that is take home that you take over 72 hours. And it'll be basically the same format as the assignments that you've had up till then. We'll be doing this lecture every Monday. We'll be doing the Thursday practicals from 10 a.m. to noon and the Friday practicals from 4 to 6. Thank you to everybody who responded to my poll about changing the time of the Friday practical. There wasn't a time that everybody could make, so I'm just going to keep it at the time that's scheduled. So I'll be around from 4 to 6 on a Friday afternoon. I'm happy to work with you then. I'm sure that Tom and Lenka will also be there. So we'll just have a, a nice Friday early evening together doing data science. So yeah, that's the kind of main content that I wanted to bring up in the course. Is there any other questions on course organization or structure or stuff like that? How long approximately would you expect each assessment to take? Okay, so each assessment has been calibrated to kind of be doable in about 72 hours. So I'm expecting you to learn the main concepts and then be able to go through and just answer the questions. I'm not looking for a huge amount of detail or a lot of writing. Normally it's just, what is the correct answer to this query? You know, fit this model, or tell me what the average price is in this group of housing listings. So approximately, you should be able to get it done in somewhere between 4 to 6 hours. If you're finding that it's taking you longer than that, immediately let me know, because this course needs to be tuned to what's feasible. These were used partially last year, and I've revised the assignments quite a bit because there's been a change in topics and a change in coverage. So if you're finding them just to be impossibly long, that's okay. Let me know and we'll figure it out. So, but I anticipate it to be somewhere between 4 and 6 hours. Will you have access to the Haggett for the 72-hour assessment? Isabel Barker also asked a question. I'll get to that, Isabel, in a second. Kate, my understanding is yes, you will. However, I need to ensure that that's the case. There's no timetabled section for that 72-hour assessment at this moment. That said, there is a digital option for remote desktops that will be shared, I think, with all students, or maybe has been already, from the Digital Education Office, where you're able to kind of use a laboratory computer from within a browser tab. So that's the kind of preferred option if you need to run these kinds of models on a computer that isn't your own. My recommendation is normally that students get the software installed on their own computers, and I'm happy to spend a large section of the lab on Thursday getting that set up for students. So I don't know if the Hagit will be sort of available for the 72-hour final, but we definitely will have time to work together in the Hagit that's timetabled for the assignments each chunk. Does that answer your question? I hope so. Awesome, great, thanks. So Isabel asks, I only chose the most preferable auction. Were we meant to select all the times we could do? Yes. I was hoping that people would get that from sort of the determination of, select the times, plural, that worked for you. But I mean, I could have made that more clear in the survey. Regardless, I found that there is I think the Africa course is being taught from 9 a.m. to 12 on Fridays. So in order for us to change the time remotely, we would have to be able to stick it at noon and go noon to 2. And then the Hagit is not reserved for that time. So students that would want to attend that lab in person would not be able to do that on Fridays. So I think it might just be reasonable. I can reopen the survey and we can sort of reassess. Okay, yeah, I heard from another student, thanks Noah. I heard from another student that it was instructed at 9 to 12, or that they needed to attend something from 9 to 12 for the Africa module. So if you can check and get back to me, I'm happy to reopen the survey, but I'm only going to reschedule if everybody can make an alternative time, because I am not going to disadvantage students that can't make the agreed upon alternative time. But I figure that most students probably don't want to attend something that's 4 to 6 on Friday. So at least I remember when I was your age, I probably wouldn't have attended that lecture or lab or whatever. So cool. So Isabel, yeah, I'll recirculate the information on the poll and then we'll see what happens. So are there any other questions on course organization, scheduling, marking, assignments? Grace asks, you said that you would be going through the answers to the lab during the Friday session. Will that be recorded / available after the session too? Yes. All lectures, I'm recording this live, and all lectures will be posted to replay. So I'm manually doing that because Zoom doesn't have any integration with the university, but I will post that to the replay site. I will make sure that it's published in the syllabus as well as on the Blackboard so that you know that it's been posted. But at least for that Friday question and answer session and any lecture that I do on the Thursday practical, that will always be posted no matter what. So I will always make sure that that's available. That said, I hope that people attend synchronously so that we can kind of get this co-learning thing going on. Awesome, thank you for that question, Grace. Are there any other questions about logistics, recordings, scheduling? Cool, okay. If Blackboard continues to be challenged in its provision of a space for discussion and chat, I may select an alternative platform for there to be kind of like a text-based discussion forum. The university recommends using Microsoft Teams, and I'm kind of don't want to proliferate all over a bunch of different platforms, but I would like to make sure that there's a place where students can gather and talk in a sort of chat room or forum capacity. So we'll see what Blackboard looks like. I know that it's the first day, so it's understandable that it's kind of screwed up. But yeah, we'll see what goes with that. So cool. Okay. Well, for the second half, I propose that we move to sort of an introduction to this chunks concept. I'm not seeing any other questions or any other hands raised. So great. Cool. Okay. So oh wait, oops, I need that one. So data science is basically a extremely flexible and ill-defined term. Instead of talking about, Emma Hartley asks, would people be interested in making a Facebook group? I think that that's a great idea, and I would highly recommend it. Either that or like a WhatsApp group or something. Like, I don't care what platform, but if there's something that people prefer, that would be killer. So please do. And I'm happy to be in that if you want me to, or I'm happy to not, whatever you want. But definitely make sure that you build that space because it's super important. Cool. Awesome. I'm really glad to see it. That's great. So if everybody is good on making a Facebook or a WhatsApp, awesome. Okay. Then I'll move on to the discussion for today. So data science is a incredibly ill-defined term. Many people have talked about how it's meaningless or it doesn't actually describe a coherent collection of thoughts and practices. And so it's kind of a contested concept at the moment. The important thing for this course is that you operate on the understanding that data science is kind of a very self-aware and self-critical way of working with data. So data science is about everything from making sure that your problem is efficiently represented in data and the way that you've encoded your spreadsheet makes sense to programs that you're going to use in analysis, all the way through to, as I said before from the Tukey quote, approaching the problem where it is rather than trying to fit it into an analytical structure that maybe is not appropriate. And then all the way out to making sure that you're representing that data in a faithful and interesting way that sort of presents all of the picture and not just parts of the picture. So there are a couple of essays on what data science is and is not, and I might post those if people are interested in that reading. One of the most famous ones is an essay by David Donoho about 50 years of data science that talks about from its kind of start with this essay in 1960 from John Tukey, a famous statistician, all the way up till now about sort of how data science has been a process in statistics. It's more of a way of thinking than it is any kind of single technique or collection of techniques. So what I'd encourage for this term is for you to think of data science as a way of representing data. And that way of representing data and engaging with data is programmatic. So data scientists are interested in making sure that what they do is repeatable and that it's a process all the way from reading the data to constructing the model and plotting the result. So with that in mind, I'm going to be covering primarily in this next chunk the theory of programmatic data. So there's all of this data in the world collected at an increasingly rapid rate. But if that data isn't clean, or as Wickham suggests, isn't tidy, it can be extremely challenging to use that data in analyses. So all of the data analysis that we're going to do in the course is going to first require that you assess whether or not the data I'm giving you is in a tidy format first. In order for you to do analysis, you have to get it cleaned up. So I've linked this paper in the description of the lecture, and I've also given you a link to the reading in the R for Data Science on tidy data. So I highly recommend that you read the paper and you read this section before we sort of get too into the weeds. But what I want to show you a little bit of is the ideas behind data shaping. Is the text on here large enough for everybody to see? If I can get a thumbs up or a chat. Awesome, great. So let's say we read in some data first. And this data is Bristol temperatures. As you can see, you have each year is a row. So you can see that when in the format of the data here, the temperatures for 1904 is that row. And the temperature for 1906 is that row. The temperature for 1908 is in that row. And in each column, we have 1 month. So one column will represent May. And all of the data in here is from May. Okay? So when we abstractly represent what each value of the cell has, we might say that this observation here is a temperature, T, in a year, Y, in a month, M. So it's one temperature in 1 year in 1 month. Now, the way the data set's been arranged has years on the y-axis and months on the x-axis. In Wickham's language, the T, the temperature, is called a value. Everything else about that temperature, when it's observed, who observed it, that is called a variable. One instance of measurement is called a record. So in this data, our record is this row. Let's erase. One record is 1 row. So that is the record for 1909. And that record contains 12 values. They're considered to be separate measurements in each month. Now, from Wickham's perspective, in the paper and in the chapter, you'll see that temps, I need to stop annotating. So temps has that sort of structure where each record is a year and each column is a monthly recorded observation. However, an alternative way to represent that data is by using a pivot. We might also have a table that looks like this. And that table now has a different structure. In that table, my record is now very different than it was before. One record contains a value for the year, a value for the month, and a value for the temperature. Same data. All I've done is taken it from the wide format that we had above, where we had a year column and then each row was the measurements across the year. We've taken that and we've converted it to what's called a long format, where now all of that information has been stretched downward, and each record represents one time, 1 month, and 1 temperature. So the interesting thing about this is that this value of temperature is still a time, or a temperature, sorry, with a year and a month. But what's different about that? Now, each of these individual bits of information about that temperature, my Y and my M, they're represented in their own columns. My year is in the year column. My month is in the month column. So they're fundamentally the same data, but they're differently structured. One of them is considered long because it's got many, many, many more rows. And one of them is considered wide because it's got many rows or many columns representing individual months. Wickham talks about 3 rules that you need to have tidy data. And I'm going to pull those up just to show you. Is melting. Yeah, good question. I'll answer that in 1 second if I can. So yes, here we go. Actually, it's done here. Great. So Wickham's 3 rules are that each variable forms a column. Each observation forms a row. Each type of observational unit forms a table. So back in our earlier example, in R, let's look at our wide data. Each observation is in a row. As long as we consider an observation to be the yearly temperature in every month. Each variable is not in a column. So there's no information about what month each value has because it's all been stretched over the columns. The way for me to filter out, temperatures that all happen in March is to grab the March column. The actual information about what month an observation is made is not actually in its own separate variable. So according to this, the data set is not tidy under this theory because all of the variables are not stored in their own columns. That doesn't mean the data is worthless. Doesn't mean the data can't be analyzed, but it does mean that the data is not tidy. However, this data in this long format is tidy. Each observation has 1 row. Every variable, year, month, and temperature, has its own column. The way that you can remember that, or try and make sure that your information is in a tidy format, is again thinking about if I have a temperature in a year, in a month, then this needs to be a column, that needs to be a column, and that needs to be a column. Every specific bit of information that you can say that you have a measurement about needs to be represented in its own column for the data to be tidy. Further, each row has to be a distinct observation or measurement. If you mix those things up, it can be helpful in some forms of analysis or plotting, but then your data does not become tidy in this sense. So all of what Wickham's talking about and all of the tools that we will be using for analysis in our class are about tidy data. You might get data that's untidy and you have to transform it to become tidy. So Bronwyn asks, in the Wickham paper, he also talks about melting. Is this the same as pivoting? So melting is a special type of pivot. Melting is when you get the data into the longest form possible. This form that we've done here is pretty close to the longest form possible. However, I could still melt it even further, saying by only having a single column and then having the record value in that column. So I could have a bunch of Januaries, a bunch of 1900s, and then the temperatures. So melting is just about moving from wide to long. And in the language of the Wickham paper, the alternative to a melt is a cast. So you melt the data down and then you cast it into another format. We will primarily be using pivoting, which has pivot wider and pivot longer. So the whole point of a pivot is to come up with a term that talks about transforming your data. Melt and cast were two words to describe different directions in which you're transforming the data, which is why Wickham and the environment that he's kind of built around tidy data has moved away from those languages. So you'll find online, hundreds of thousands of different tools that people have written to do pivoting or melting and casting. But we're going to be focused on these pivot longer and pivot wider tools. Specifically, we'll be focusing on the ones that are available from this library called Tidyverse. The Tidyverse is a collection, not Tidverse. The Tidyverse is a collection of packages in R that all have sort of a similar functionality. So each of these packages are Tidyverse packages. That means that they either work with tidy data, or they provide tidy data, or they consume tidy data and transform tidy data, whatever. So they all fit into this kind of neat data analytic system. So what I show in the lab is that there are ways to do these pivoting operations and change data from an untidy format into a tidy format. The first one that we just did was called a pivot longer. So we've taken our wide data, which has the year column and then months spread out over columns. And by using temps, pivot longer, I can say from January to December, we want to pivot those down. If I run that, I get a data frame that looks like this now. So I've taken the input data frame, which is temps, and I've pivoted it longer by taking the January through December columns and stretching them out into a column called name. Does everyone see that? I've gone from something that has a bunch of columns plus year to something that just has year, name, and value. So I've taken the wide data and I've squished it down long. Now there are other options that we can use to rename those columns. So here I'm using names2, which lets you convert the name column into something else. And I'm calling it month. So all of those columns in our original data need to get pivoted into a single column called month, because that is a variable that describes the time at which the observation was taken. In the original format, it was stretched over columns. In our tidy data, every variable has to have its own column. So this pivot takes that data and converts it into the tidy format. If I use this, now my data is year, month, and value. Now there's another option in the pivot longer, which is values 2. And with this, I can transform the data frame into the format you saw before, and that's present in the lab. So that's just one transformation, going from a wide data set to a long data set, and in the process, constructing something that fits Wickham's definition, where every row is a single observation, every column is a variable, and then the only things in a single table are consistent about the type of observation that they have. So every single record has to have the same sort of representation. In the rest of the workbook, I go through a couple of different tidy examples and reasons why you might want to use tidy data or reasons why you might not, ways that you can get around having to have tidy data. So I just want to show one example here. So the pivot that we just did was this one here. If everyone can see that, we used a pivot longer to take all of these columns in the top table and cast them into a single column in the month table. Now, you don't always need to do that to get analytical results. So some tools that you can use in R are not tidy, and they can just give you results and plots if you want. So you can get, plots of temperatures by years or things like that because R has been built long before tidy data was even sort of a thought. But using things in tidy format lets you use all these other tidy tools as well, because it's a canonical representation of the information in your data. So another example that I want to show you is this example, the climate curve for Bristol. So a climate curve is a plot of the temperatures by each month. And in our original example, every column was its own month value. So if you just plot each row of that original data frame, you could get a climate curve. If you transform it, you can also get the climate curve. So when you work through this workbook, what I want you to keep in mind is that just because data isn't tidy, just because data is mixed, it doesn't mean that it's impossible to use in an analysis. Tidiness is just a concept where every record, every row is a single observation, every column is a variable, and every value is a unique description of the same phenomenon. That's it. So we're going to use a bunch of tidy tools, and we're going to involve a lot of stuff that sort of complements these ideas. But when I'm talking about tidy data, all I want you to do is be able to think does the data set follow those three rules? Every variable needs to be its own column. Every row needs to be its own unique description of a single measurement. And then only the same types of measurements should be collected together in the same table. I don't quite have time to move on to anything else additional to that. So at this point, I'm willing to take questions on what tidy data is, how tidy data works, if there's any kind of interest in that. So I'm ceding the floor to anybody who wants to ask any questions. Is Wickham's view of tidy data just one of many? Yes, it is. If you read the Wickham paper, he mentions something after he provides this definition that I've given that, you know, every variable is a column, every row is a single observation, and every sort of table contains the same observations. But Wickham suggests that this is actually this guy Codd. I think it's a paper in 1980 something, maybe 84. It's the Codd third form. So that would suggest that there are many other forms that are not just this form. So this idea of tidy data is just one of the possible representations in like a canonical format. However, you'll find in R that nearly everything is moving to this as a canonical representation of data. And there are a couple of reasons for that. One is that it's really easy to take data in this format and put it into high performance databases. So everything that you do in like a company or a, you know, social media analytics kind of situation, it's all going to look like this. It's all going to be records and variables with a distinctive type of observation in each row. And that's, you know, Codd was a innovator in the theory of what they call relational databases. So he needed to identify all these different abstract forms that data could take and then define transformations to a single representation that was easy to sort of store and do computing on. So the reason why people like Hadley's particular presentation is because it encompasses a lot of commonly encountered problems in data analysis. So if you do the reading, you'll see that there's kind of an allusion to the fact that there's a lot of thinking going on around the edges of this, and his perspective is just one. I've also linked to an alternative perspective, sort of a critique of the tidyverse in some of the material for this block. So you'll get kind of exposure to all these different things, but basically anybody who's working in R is learning these kinds of tidy tooling and structuring methods because it's an efficient way to work with data. But it is only one way to work with data. Rasters, they don't really fit into this very well. You can make a raster tidy, then you got a huge long thing with a bunch of coordinates and then the values of the raster. It's not as efficient. So it's just one way. Many tools use it well, but it's only one way. Great question, Hannah. It's probably time for one more question, and that's about it. Okay. Well, so then on Thursday, what we'll do is we'll kind of go through the workbook. I'll talk a little bit about sort of more specifically what's going on in the code of that notebook. And I would just like to treat it as kind of like a, maybe not a co-working session, but kind of a time for us to be together and you to work on the workbooks and get through the kind of coding content while we're all together. By a quick show of hands, would people be interested in doing like a setup kind of session where I walk through how to get the libraries installed and all that kind of stuff? Like, would you like that? Okay, some people. Okay, I'm happy to run that then. Obviously, like if you get RStudio installed, you'll have most of the software that we'll need to use in the course. So what we might do on that day then is we'll do a setup for the first part where we'll just walk through how to get RStudio installed and the various packages that you'll need. And then we'll just proceed. So I'm really happy to kind of let you work at your own pace. That's why I've posted everything online. And please, please, before I forget, my office hours are available around this course time. So Monday afternoon all the way up till 6 o'clock. And I'd also really like to be able to meet with you in person, or well, not in person, but individually, to facilitate kind of any questions and or learning that you want. So I would kind of treat it as a little bit more of an individualized, tutor-driven model than kind of a course where I'm expecting you to listen to me lecture and then regurgitate the stuff that I've told you back. So I'm expecting this to be much more self-driven, inquiry-driven, and collaborative. So awesome. Okay. Thank you, everybody. Again, I can't reiterate enough. I'm so excited to be teaching this course this term, and I'm really looking forward to what we get up to. So great job, everybody, and I'll catch you around.